the brass is what? 4/3. Okay, so the brass did not change. Right? The brass did not change at all. Hold on. But now the thickness of the what? The steel changes because it's twice, right? So this is brass. So the top part and the bottom part are our steel. So the width changes. Right? So this is our width. So now the top and the bottom, they are still equivalent to brass. Okay. So let's look at one example. Okay, let's look at one example. So you will find this example on Avenue to Learn. I posted the examples that we're going to do. So if you can download the examples, okay. So I'm going to call our example. Right. So this is example number 1. So the top plate is made of aluminum and is used to reinforce a Kevlar plastic beam. Okay. Determine the maximum stress in the aluminum and in the Kevlar if the beam is subjected to a moment of 900 pound-feet. Okay, so that is the information that is given. Okay, so by looking at the problem now, by seeing the problem now, so this top bit is made by aluminum. Okay, and then you have this part, this part, and also this part is made of Kevlar. Okay, and what we can see, we will draw our transformation first. Right, so this is our transformation. So I will declare that this is our X, right? And then the vertical, this is our Y. And then we have another one. Right? So this is our Z. Okay. So we have to find the information, okay, that is actually that I will provide if this question were to come out, is that the Young's modulus of aluminum is equal to 10.6 times by 10 to the power 3 psi. Okay. Whereas Kevlar, okay, is a stiffer material, 9.0 times 10 to the power 3 psi. Okay. So we know the formula that we're going to use. So we're going to find stress in the x direction is equal to N multiplied by mz over izz multiplied by y. Okay, so that's a formula that we're going to use. So we decide what is the reference material to use. Okay, we decide. Okay, we decide what we. So for this case, I'm going to use the reference material Okay, the reference material to be aluminum. Okay, so and for aluminum is equal to Young's modulus of aluminum divided by Young's modulus of aluminum. So this is equal to 1. Okay, so the one I highlight, so this is our reference material, aluminum, right? And then the N for Kevlar, okay, is equal to E of Kevlar divided by E of aluminum. So this will be equal to 19 times 10 to the power 3 divided by 10.6 times 10 to the power 3. So this will be equal to 19 divided by 10.6 is equal to 95 over 53. Okay, so from here on, we have to now determine the centroid. We also have to find the second moment of area. Okay, and then we know that the second moment of area is equal to I. So we can find IZZ is equal to N W or width multiplied by D cubed over 12 plus by N W, the area multiplied by Y bar minus by small y bar squared. Okay, right, so now we're going to do that now. Okay, so I'm going to copy the question. Okay, can I move to the next page? Anyone still writing, or we're okay? We're okay. Okay, so I'm going to, so that when I refer to the diagram, we can always see it. Okay. Can I crop the image? Oh, I don't think I can. Okay. So I'm going to just make it over here so it's easy for you all to see. Right. So if we look at our material now, okay, I'm going to sketch this out. So we have 6 inches. Okay, so we have 2, 4, 6, and then 2, 4, 6, 8, 10, 12, 12, and then I'm going to have a 1, right? Then bear with me, okay? Then we're going to have this, and then we're going to have this. Okay, so this is my simple sketch. Okay, so 2, 4, 6, 8, 10. Eugene. 8, 10, 12, 13. So 0.5. Oh, it's about right. I only got the thickness wrong. So this is how it should look like. 0.5. 0.5. I do apologize. So this is also 0.5. Okay. Now this is correct. Okay. So this is our aluminum. This main part is our Kevlar. Okay. Right. So you can see that. So I'm going to call this into section. Okay, so I'm going to declare this the aluminum as section 1. Right, I'm going to divide our structure this way. This is going to be my section 2, section 3, and this will be my section 4. So remember what I told you is that we make Kevlar as the reference material, right? We make Kevlar as the reference material. So what will happen is, so schematically, what have we done? Okay, schematic. So what we have done for making aluminum as the reference material, right? So this did not change at all. Okay, this the size of the aluminum remains the same, right? Because we make this as the reference material, right? Aluminum. So section 1 did not change, but the rest of it, the width, right? The width divided by 50, they amplified by 1.8 times. Okay, so geometrically, I'm going to briefly sketch. So only the width changes. Okay, so the width changes by 1.8 times. Okay, so this is the width. Remember what I told you, the depth did not, the geometry of the thickness did not change. Okay, so now our thickness is 1, 2, 4. So the thickness did not change. The thickness is still the same. Okay, so this is our Kevlar now. Okay, hold on, let me see. Okay, so this is our Kevlar. And the other 2 pieces, the thickness changes. All right, it becomes thicker. Okay, so this is our part 1, 2, 3, and this is material number. So this is what is going on. Okay, so the first thing we're going to do, right? So the schematically, I just draw for you what does it look like. Okay, so now we're going to find. Okay, let me put this down so I can get the dimension easier. Okay, so we're going to find the centroid. Right, so if we go back to this diagram over here, so this is my y, this is my z. We're going to find zz, right? So this is our zz axis, right? So parallel to the zz axis is our width. Perpendicular to our zz axis, this is our what? This is our depth. Okay, so the way we divide our structure, right? So we're going to call section. Okay, we're going to have our section. We have section 1, 2, 3, and 4. And because it is a composite material, we need to also know what is section 1 made of, right? So we know that we write down the material, right? So we know that this is aluminum, the rest are Kevlar. Yeah, the rest are K for Kevlar. And then we know our N. Okay, so that's our coefficient. So aluminum is 1. The rest we found the coefficient to be 95/53. Okay, that we know. And then from here, same thing now.